Okay, example 14 says the amount of copper ore produced from a copper mine in Arizona is modeled by this function. Remember, we said if you have the function or the equation given, that's good news. You just have to know what each of the variables stand for. X is the number of years since 05, and f of x is measured in thousands of tons. So let's keep that in mind. And as far as we're concerned, so x is the number of years since 2005. And as far as we're concerned, we could call this, even since we were dealing with an equation with x and y, f of x is just like a y value. We'll talk about this and remind you of functions later. For right now, I'll even go ahead and just call that y, or the output, which will be the thousands of tons of ore. So most important thing is to know what the variables stand for, because then from there on you can interpret the problem in an easy manner. So part A says just give a sketch. We know it's a linear function with y-intercept b 200 and a slope m of 32. So a rough sketch, we'll say x is here, y is here. It starts at 200,000 tons and then it just keeps going up because it's got a positive slope, something like that. So we'll do a quick sketch with starting at 2,000, increasing because of the positive slope. Part B, we already answered that question. What is the slope of the graph? Well, that's the m value right here that we pulled out. So the slope is 32. And part C says at what rate is the amount of ore produced changing. Whenever you're asked for a rate, in your head you should think they're asking me for the slope. So a rate or rate of change, we'll talk about it that way later also, simply means what is the slope. So at what rate is the amount of ore produced changing? The slope here is 32. Remember, we said it's good to interpret the slope if you put it as a fraction. It's 32 over 1. We know a slope is change of y's over change of x's. We were looking at difference of y's over difference of x's. And if we do our labeling of units correct, in the y's we have thousands of tons. In the x's we have a label of years since 2005. So that's going to be years, which means the rate basically is changing by 32,000 of tons per year. So the amount of ore produced is increasing because it's a positive slope at this rate. Let's write that as a sentence. So we can say the amount of ore produced is increasing, again increasing because it's a positive slope, by 32,000 tons. All I did was just follow the units I had labeled here per year, since I have the x's be in units of years. So once you label your slope, what the y's represent in the numerator, what the x's represent in the denominator, the interpretation of what the slope is or what the rate of change is becomes pretty easy. Let's go look at example 15 also. So it's saying biologists have observed that the chirping rate of crickets of a certain species is related to the temperature, and the relationship appears to be very linear. So that means we can come up with the equation of a line to describe this relationship. A cricket produces 120 chirps per minute at 70 degrees Fahrenheit. So that's our first piece of info. That many chirps associated with 70 degrees. And the second piece of info is that 168 chirps happen when the temperature is higher at 80 degrees. Part A says find a linear equation that relates the temperature T and the number of chirps per minute N. So they're already giving us the variables, how they want us to call it. So the temperature is T and the number of chirps is N. So I'm just going to make two ordered pairs because they said find a linear equation. So for part A, just as I see them, I'm going to say 120 chirps for 70 degrees and 168 chirps for 80 degrees. And with those two ordered pairs, I'm just going to go find, I guess, the equation of a line. And if you change the ordered pairs and you wrote it as 70, 120, and 80, 168, also would be okay. You would be relating the two with a different order. They didn't tell us which one to call the x, which one to call the y. So I'm just reading them in order and putting the first one as my x and the second one as my y. So in other words, I'm putting it as n and temperature, n as temperature. Now let me go find the slope first. Two ordered pairs, find the slope first, then go find the equation of the line. So I'll do m equals second guy minus first guy in the numerator for the y values. In the denominator, second guy 168 minus 120 in the bottom for the x's. That'll be 10 over 48, and they're both divisible by 2, so that's going to be 5 over 24 as my slope. Now that I have my slope, I'm going to use the point slope form of a line, and one of the ordered pairs, maybe this one, and let's just go plug them in. Y minus 70 equals, we found our m, plug that in, x minus 120, plug in our x, and then let's go simplify it out. So we're going to have y minus 70 equals 5 over 24x minus 25 when I multiply that fraction with the 120. Let's move the 70 to the other side, and then we'll adjust our variables based on how they want us to call it, t and n. 5 over 24x, I guess, plus 45 it looks like. And since this was my x, and this was my y, I'm going to go adjust them accordingly. They wanted the y to be called t for temperature, 5 over 24, and they wanted the x to be the n for the number of chirps, plus 45. So that would be a plausible linear equation that relates the temperature to the number of chirps. Part B says, if the crickets are chirping at 150 chirps per minute, so they're giving me the number of chirps, in other words, they're giving me the n value, estimate the temperature. Okay, so we can recycle the equation we just created to relate the two and replace the n with the 150 chirps that they gave us and see what happens when I plug that in, what estimated temperature we get. So let's go punch that in, and it looks like we're going to end up with 76.25 degrees Fahrenheit as the temperature when there are 150 chirps per minute. So all we did was read the information, make the information as two ordered pairs, and find the equation of a line that goes through those ordered two pairs, or two ordered pairs, and then we relabeled our x and y to be the appropriate variables they wanted us to call it. And in part B, it was simply a plug and chug. Put in the n value, get the t value out. And that's it for example 15.